Now we're going to continue with exponents, and now we're going to actually look at exponential equations. And you'll need a pencil and a calculator, and you want your book open to page 115, so we're going to go back to the workbook. And had you been in class, we would have started off by doing some of the problems 7 through 12 on page 118. We're just going to go right into the lesson from the very beginning. So the first person we look at is that we have students are asked to write an equivalent expression to 3 to the negative 3 power. Okay, so we're going to do that. Now we've just been going through negative exponents, so we should be pretty good with that. We know that a negative exponent sends it to its opposite place. So we know that it sends it to its opposite place. It's in the top, in the numerator, so it's going to send it to the bottom or the denominator. So now, and that's the best way to do it. So it says Casey and Juanita each write an expression on the board. Who is correct? So by us taking and simplifying it to begin with, we can look to see who is right. Okay, and we can see that Juanita is right. Okay, and the reason Juanita is right is because when we have a negative exponent, it goes to its opposite place. What did Casey do? Look at that. What did Casey do? Okay, well, Casey thought, hey, I have a negative exponent, so therefore it's going to become a negative number. Okay, now she did take 3 to the third, or they did take 3 to the third, but the negative right here talks about location, not value. Okay, so Juanita is correct because she took it down. What is the most likely error that was made? Oh, we already talked about that. We have a negative here. A lot of people think that if I have a negative anywhere in this, it's got to be a negative up here, and it is not. So we're going to look at the first problem that's in your book, and again, this is hopefully just review from the quiz that we just took. So what does 2 to the third equal? But remember, if whatever is in the denominator, that is your root. So we can rewrite this to be the cube root, because that's my denominator, of 2 to the first power, or just the cube root of 2. Now 2 itself is not a perfect cube, so that's all we can do. This is in this is in exponential form, this is in radical form. Okay, now before we go any further, I just want to refresh your memory on some of the rules that we have. If I have x to the third times x to the fourth, that's going to give me x to the, when I multiply like bases, what do I do with my exponents? That's right, I add them. So that's going to give me x to the seventh. Yes, do you remember that? Okay, so keep that in mind. We're going to use properties that we did, those last properties we did before coming back into the book. We're going to use those again. Now, another side note, if I have something like, let's say, 5 to the x is equal to 5 to the seventh. Now notice that these two things are said to be equal. These two things are equal. 5 to the x is equal to 5 to the seventh. So just think logically for a second. Just think about that. And if I have that both bases are 5, what do you think we can say about x to the 7? Okay, if these two things are equal, then doesn't x have to equal 7? Okay, think about that. So we had 5 to the x is equal to 5 to the 7th. Those two things are equal. So if those are equal, doesn't x have to equal 7? So if my base is the same, then, and it says that it's equal, then my exponents have to also be equal. Okay, go to the next page. So on this one, we have, what is the solution to this equation? So the first thing I want you to do is just ignore this. Just pretend like nothing there, okay? Nothing to see here, people. Move on. So now we're going to look at, we have like bases. When we have like bases, and I want to simplify, what can I do with those exponents? That's right, I can add the exponents. So this gives me 2 to the x over 4 plus x over 6. Do you see that? Okay, now let's bring this other thing back in. So what this is saying is that the left side has to be equal to the right side, yes? So x over 4 plus x over 6. Look at that. And notice my bases are both 2. Both 2. So if these two things are equivalent, if this side is equal to that side, then that tells us that this right here has to be equal to this right here. The exponents have to be equal. If it says that it is equal, and my two bases are the same, then my exponents have to be equal. Yes? Are you there? Good. Now what we're going to do is we're going to take the two circled parts. That becomes our equation. X over 4 plus x over 6 is equal to 3. That becomes our equation. Okay? I realize that what's in red, this is our original equation. But once we can get it down to the bases are exactly the same, then my exponents have to be equal. Okay, now we just solve this equation, and I make it sound like, I just now solve this equation. So I have fractions. How do I get rid of fractions? That's right, I multiply through. I clear the fraction by multiplying through by a common denominator. So what could be a common denominator between 4 and 6? You might think 24, that's a great one. You might think 12, that's a great one. It doesn't matter, you're going to pick one of them. I'm going to pick 12. Nah, I'm going to pick 24. Oh gosh, I can't decide, I wish you were here. So I'm going to multiply by 24. Remember, when you clear fractions, you have to multiply every single term by 24. Okay? So now we're going to get that the 4's drop out, or divide by 4, I get 6x. Divide by 6, I get 4. And now, but you're back with calculators, so not a problem. 3 times 24, 672. Now we're just going to solve this equation. 10x is equal to 72. Divide by 10. X is equal to 7.2, not 7.5. Sorry about that. 7.2. So what does x equal up here in these original problems? It equals 7.2. Okay, I know you're going, what? This gets so bizarre. Yes, it does. Hello and welcome to Algebra 2. Isn't it cool? I mean, it's just amazing. So let's look at the next one. Well, actually, this next one is not in your book, but I wanted to have a little more practice. So just do this one with me. Okay, so in class, you would probably be doing it in the left-hand column of your workbook. So just go ahead and put that there. So now notice all of our bases are 3. That's huge. And you'll see pretty soon we actually have to make it that way. So all of our bases are 3. So we can just go with our rules. And again, cover up this side. Just ignore that right-hand side and look at the left-hand side. I'm multiplying like bases. So if I'm multiplying like bases, what am I going to do with the exponents? Listen to my words. Multiply like bases, then that's right, add my exponents. So this is 3 to the x plus 2 over 2 plus x over 3 is equal to 3 to the 9th. Okay, try it right now. Pause yours, see if you know what to do next. So hopefully what you did, oops, don't need to move that 2 around. Hopefully what you did is that you saw that these exponents also have to be equal because the whole thing is equal, so therefore my exponents have to be equal. So I came over here to the left-hand side and I wrote out that equation. X over 2 plus x over 3 is equal to 9. Again, we're going to clear the fraction by multiplying through by a common denominator. Our common denominator here is obviously 6, so every single term gets multiplied by 6. When I do that, I can divide by 2, I get 3x. Divide by 3, I get 2x. 9 times 6 is 54. Now we're just going to solve this equation. Go. So we found out that x is equal to 10.8. Okay? Great. So it's not anything you can't handle. It's just weird, bizarre, and really cool. Okay, next one. Let's look at the next equation. Now this one is back in your book. Now it gets a little more complicated as we do this one because this time my base is not the same. So what we have to do is we have to force it to be the same. So take out your calculator right now, and what we want to do is we want to see if we can write 256 to a power of 4. So take out your calculator. We know 4 to the second is 16, 4 to the third is 64. Try 4 to the third. What do you get? So like I said, we know that 4 to the third is equal to 64. Hopefully with your calculator you took 4 to the fourth. If you forgot how to do that, look for that tenth. Okay, so 4 tenth 4, and you're going to get 256. So what we're doing is we're forcing the base to both be 4. So we're going to rewrite this. So this becomes 4 to the fourth all to the x plus 2 power is equal to 4 to 3x plus 9. Okay? So we know that once our base is the same, both of them are a 4. Once those are the same, we can just take the exponents and those are equal. Okay, now over here, what you need to remember, when I take a power to a power, what do I do with my exponents? That's right, I multiply. So this is going to get multiplied. So this is going to be 4 times x plus 2 is equal to 3x plus 9. Because if my base is the same, then my exponents have to be equal because this says this is equal. So if it's equal, the exponents have to be the same. So now you're going to solve this green equation. Go. So from this very complex equation right up here, we get x is equal to 1. Who would have guessed it? Pretty cool, isn't it? We're going to get to practice some more of these later too. Okay, so this one gets to be even more fun. I think they're fun anyway because these are totally a game. We have to get the base to be the same. Now, can I make 4 to an exponent be equal to 8? So 4 to the second power is 16. 4 to the first power is 4. So that 8's not going to work. So now what we have to do is rethink. How can I get 8 and 4 to be the same base? What number could I use? Hopefully you came up with 2 because 2 to the second power is 4. 2 to the third power is 8. So we're going to rewrite this one. And notice both of them are under. Both of them are denominators. How can I get them to be so I have 2? Couldn't I make this one? Maybe I'm going too fast. Okay, hold on. So let's do this first and then we'll go again. So this is 1 over 2 cubed. It's still to that x over 2 minus 1 power. This is 1 over 2 squared, all of it to the x over 3 power. Yes? Are you with me? So I took 8, rewrote it as a power of 2. I took 4, rewrote it as a power of 2. Now, I have them in the denominators. How can I make them just come up? Well, if I make it a negative exponent, so if I write it as 2 to the negative 3, okay, because it was in the denominator, now becomes a numerator. And that exponent did not change. 2 to the negative 2, all of that to x over 3. Feel free. Oh my gosh, what did I do there? Look, that's just weird. Sorry about that. This is x over 2 minus 1. That's my exponent. Okay, so what we have to realize now is that now my bases are the same. So I can just take care of my exponents. When I take a power to a power, I multiply. Power to a power, I multiply. So that's negative 3 times x over 2 minus 1 is equal to negative 2 times x over 3. Woo! Well, wasn't that fun? Yeah. Okay, so here we go. We got this. We can do it. So we're going to distribute right here. We get negative 3x over 2 minus negative 3 times negative 1 is a positive 3. So I found a mistake when I was going back through it. I found out I took a negative 3 times a negative 1. That's going to give me a positive 3, so a positive 18. So that's just going to give me a positive 18 over 5. So sorry about that. Now, if you saw some other things flash, don't worry about it. So for now, we're going to skip ahead in your book. We're going to actually go all the way over to page 118. So turn to page 118, and we're going to go to the essential questions. So what are the properties of rational exponents, and how are they used to solve problems? So in order to solve some of these equations, we use like, what was that? Power to a power exponent, we used that. We used a power of a product, power of a quotient. So we had to use all of those properties that we learned, and we're going to apply it to solve equations. The next one is a square has an area. What are the 2 ways of expressing its side length? We're not going to worry about that one right now. Next one. Look for relationships. If 3 to the x equals 3 to the y, what is the relationship between x and y? And this is what we've been talking about. If my base is the same, and I have an equal sign, that means my exponents have to be equal. The exponents have to be equal. Okay, so here's an error analysis that we're going to look at for Corey. So Corey made a mistake here. And what Corey did is he had the cube root of 4 squared is equal to 4 to the 3/2 power. Okay, there's an error. So what you want to do is take this and rewrite that. And so that's going to be written as 4. So the 2 is the exponent and the root is the denominator. So what did Corey do? He flipped it. He flipped the exponent and the root. Okay? Good. Number 5, when is it useful to have rational exponents instead of radicals? Anytime you're going to be solving equations. So let's just go on. How are rational exponents different than whole number exponents? So a rational exponent, this is going to be a fraction if we go very basic. And then if I talk about whole numbers, it's whole numbers. So how are they different? Well, one's a fraction, one's a whole number. How are they the same? They use the properties are used the same. Properties are used the same way for rational expressions and whole numbers. For rational exponents and whole numbers. Okay, moving on. Okay, now these, I want you to try 7, 9, 10, and 12 in your book right now. We don't need to do all of them because they're kind of repeated. So I want you to try these right now. Go. Pause yours, write your answers. Yes, pause it, go. Hopefully you actually paused it. So remember, this is a square root of 7, so that's going to be 7 to the 1/2 power. Okay? Then, remember I always do the exponent, so 6 to the 4th, and then the root is the denominator. Okay, look at 10. If you forgot how to do these, hopefully not, this is going to be 2 to the 3/3. Well, look at that. Can we simplify that? Yeah, that's 2 to the 1st, which is just 2, because 3/3 is 1. Okay, now we have, right, square root of 8 to the 3rd. Okay, so this is square root of 8 cubed. So that's 8 to the 3/2 power. Okay, right, with rational exponents. Good. Now we're going to do some more solving of equations. So if my base is the same, okay, and again, I'm covering up this right-hand side with my hand, but you can't see that from where you're at. So I'm taking this part right here and I'm covering up. So just let that hang out for a second. When I have like bases and I'm multiplying, then I'm going to add the exponents. So this is 2 to the x/3 plus x/2 is equal to 2 to the 5th. So then from there, 2 to the 5th, not 25. So that would be 2 to the 5th. So then we realize from there, once the base is the same, we can set our exponents equal. So x/3 plus x/2 is equal to 5. And yay, we get to do the fun thing of multiplying through by the common denominator, which is 6. It could be 12, it could be 24, it could be 18. 6 just happens to be an obvious one. So let's keep on solving this one. So we get now, I can divide by 3, I get 2x. Divide by 2, I get 3x is equal to 30. So 5x is equal to 30. Divide by 5, and I get x is equal to 6. Okay? I'd like you to try this next one on your own. Go. So far you have added the exponents, x/2 plus x/5. Now, because our bases are the same, we both have a 4, we can set our exponents equal. What would be a common denominator you might want to multiply through by here? Well, it's pretty much multiplying the 2 and the 5. So how about if we multiply every single term by 10? So we're going to multiply by 10, and I want you to do the rest of this equation on your own because that is wonderful practice. Go. So when you solved, you got 5x plus 2x equals 80. So 7x equals 80. Divide by 7, and I get 80/7. That's a fine and dandy answer. Good. So on this last page, this is where it gets a little more complicated. Our bases are not the same, so we have to make them the same number. Is there any way to make a 4 be equal to 64? Think about it, 4 to the 2nd, 4 to the 3rd. That's right. So I can write this as 4 to the 3rd, all of it to the x plus 1, and 4 to the x plus 7. Once we have done that, we've got the same base. We still have to use our rules. When I take a power to a power, what do I do with my exponents? I multiply. So that's going to give me 3 times x plus 1 is equal to x plus 7. Yes? Solve that equation, go. So I ran out of space, but, and look, my answer, x/2. That little circle wanted to move. Now I'm going to make it another thing. So our answer is x is equal to 2. Good. Hopefully you got that. Let's look at this next one, and I'd love if you would pause your video and try to get these bases to be exactly the same. Try it. Just think about it for a second. Okay? Did you notice that 16 can be written as a power of 2? This is 2 to the 4th power. Yes, all of that to the x minus 3. Wow, we got a lot of parentheses going on here. Okay? Now I'm taking a power to a power. I have a like base. I have a like base. That's 2. So I'm taking a power to a power. That means my exponents have to be equal. My exponents have to be equal. So I have 4 times x minus 3 is equal to x minus 6. And go. Solve that. Okay, that was kind of a fluke. X equals 2 on both of them. Weird. Okay. Anyway, you're getting the idea, though, hopefully. Go to the next page. Next problem. Oh my gosh, look at these numbers. 243, what the heck? We're going to have to play with this one. So let's take 9. If I take 9 to the 2nd power, that's 81. Take 9 to the 3rd power. Nope, that's not it. So let's try 3, because I can write 9 as a power of 3. So what I'm doing is trying to get these two numbers. Okay, so hold on a second. I've got a different idea. I was going down one way, but I'm going to go a different way, so just hold that thought. I have negative exponents. Can I do that? I don't know if I can. Hold on. Hold on again. I am skipping 17 for now, because it's just doing weird stuff. So I'm just going to stop on that one for just a second. Let's go to 18. 18, we have 36, and we have 216. I have to get those to be the same number. Can I take 36 to the 2nd power and I get 1,296? So that doesn't work. So what I'm doing right now is I pulled my calculator out. I'm trying different things. So I'm not going to take 36 and square it to get 216. Okay? So let's try 6. If I could get this to be a power of 6 to the power of 2, can I take 6 to a power? Well, 6 to the 3rd power is 216. Yes. So this is 6 to the 3rd power. So I'm going to rewrite that to be, okay, this is going to, and then I have 1 over that. So I'm going to write this as 6 to the negative 2, all of it to the x minus 4. And that has to be in parentheses too. And this is 6 to the negative 3, all to the x plus 1. Now, once we get it like that, you're going, well, that was easy, because now my bases are the same, so I can just set my exponents equal. So I have negative 2 times x minus 4 is equal to negative 3 times x plus 1. And you're going to solve those two equations. So I get negative 2x plus 8 equals negative 3x minus 3. I am going to add 3x to both sides. I get x plus 8 is equal to negative 3. I'm going to subtract 8, and I get x is equal to negative 11. Okay, that's enough for now. Okay, so those are our notes that we're going to do for today. Make sure you check Schoology to see where your homework assignment is. Thank you.